Okay, so moving on, let's talk about Theorem 10.1. This is what Theorem 10.1 says. In a plane, a line is tangent to a circle if and only if, so we've got a biconditional. A line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at its endpoint on the circle. So, the radius to that endpoint and the tangent that intersects at that that point of tangency, they have to be perpendicular. The radius and the tangent have to be perpendicular. If it's not perpendicular, then it's not a tangent. That's how our biconditional works. If it is perpendicular, it is a tangent. If it's a tangent, it's perpendicular. Okay. If it were, say, 45-degree angle right there, then that line would come across this way, and that would intersect in 2 points, not a tangent. Okay, so let's use Theorem 10.1. Number 4. In the diagram, RS is a radius of circle R. So is ST tangent to circle R? So this is a radius, and it's asking, is this a tangent? So using 10.1, what it's really asking is saying, is RS perpendicular to ST? Is RS perpendicular to ST? Well, I've got a triangle, so I can use my Pythagorean theorem converse to figure out if that is a right triangle. So we'll do, is a squared plus b squared equal to c squared? So we've got 5 squared plus 12 squared. Now, looking over at this possible hypotenuse, this 8 is only referring to this segment right here. This segment right here isn't given, but we know that that is a radius. And if we know that's a radius, we know it's equal to this radius. So we know that this segment is 5 because it's a radius, and all radiuses are equal by the definition of a circle. So this entire side would be 13 squared. So is it a right triangle? Well, 5, 12, and 13, that's a well-known Pythagorean triple. So that makes that a right triangle, which makes that a right angle, which means the radius and the tangent are perpendicular. So yes, that is a tangent. So I'm going to write, that's a triple. So yes, ST is a tangent. Okay, pause the video and you try number 5. Is ST a tangent in number 5? 5? You should have finished number 5 by now. So, I said, no, that's not a tangent because this side is 12, that side is 16, 12 squared plus 16 squared equals 400. This side got a radius right there, so that's 12, which makes that entire side 19. 19 squared is 361. 400 doesn't equal 361, so no. ST cannot be a tangent because by the converse of the Pythagorean theorem, that is not a right angle. Okay, so let's do 6 together. In the diagram, B is a point of tangency. Find the radius of circle C. So if B is a point of tangency, then we know that that is a right angle. So now it's just Pythagorean theorem. This side, r squared plus 77 squared equals r plus 49 squared. So we've got a quadratic on our hands. Let's work it out. R squared plus 77 squared is 5,929 equals r squared plus 98r plus 49 squared is 2,401. I've got r squared here and r squared there, so those cancel out. Moving the 2,401 over, I'm left with 3,528 equals 98r. So r equals 3,528 divided by 98, which is 36. So the radius is 36. And we just use theorem 10.1 and the Pythagorean theorem. Okay, let's move down to theorem 10.2. Theorem 10.2. 10.2 says, tangent segments from a common external point. Okay, so let's talk what that even means. Tangent segments, so we're not talking about lines or rays here, we're talking about segments, from a common external point. So over here we've got two tangents and they're meeting at one common external point. ST, SR, tangent, tangent, intersect. So those two segments are congruent. Congruent. In this diagram, SR and ST are tangent segments, so SR is congruent to ST. Okay, so let's use this. Number 7. It tells us QR is tangent to circle C at R, and QS is also tangent to circle C at S. So find the value of X. Well, by theorem 10.2, we've got two tangent segments from a common external point, so those are congruent. So I know that QR is congruent to QS. Therefore, 32 equals 3x plus 5. So 27 equals 3x, x equals 9. Okay, so I'd like you to pause the video, try number 8 and number 9. Number 8's pretty easy. Number 9 might be a little bit tricky, but try it anyway. Okay, so let's talk about these two. So, for number 8, x is 7, because these are two tangent segments, common external point, 49 equals x squared, x equals 7. Okay, so number 9, I've done part A, I'll show you part B. So for part A, here's 12, this part's 5, this part's 21. I've shown in colors, these are all tangents that meet at common external points. So this orange part's equal to that orange part, the green's equal to the green, and the purple's equal to the purple. So if that's 5 and that's 12, that's 7. This part's also 7 because they match. That's 7, this is 21, this is 14. 14 and 14, they both match. And then over here, the orange are the same, so that's 5. So then RM is going to be 5 plus 14, so it's 19. Now, on part B, it tells us that OH is 4. What's OT? Well, okay, so OH is a radius, RT is a tangent. So by theorem 10.1, that's a right angle. Those two are perpendicular. So now I have a right triangle. That side's 4, that side's 7. So 4 squared plus 7 squared is going to equal OT squared. So 16 plus 49 equals OT squared. 65 equals OT squared. So OT equals square root 65. So that one we had to combine both theorem 10.1 and theorem 10.2.